the properties we're going to be talking about apply to all real numbers. So all those rational, irrational, integers, wholes, naturals, okay? And the first one you know already, hopefully, is the commutative property. If you're in your books, you can go to page 20. They give you examples. I'm not going to use examples every single time because we've already talked about the commutative property. What is the commutative property? They give you, by the way, they give you an equation, but I need you to explain it to me. What is commutative? Am I going here? Yes, I am. Okay, yes, Alex.
If like everything's addition, then we just rearrange the addition.
Okay, if you have all addition going on, so 2 things being added, 100 things being added, it doesn't matter the order. That's correct. So here's what I'm going to put. Order does not affect the sum or product. So technically, there is a commutative property for addition. Addition's order doesn't matter. And there's a commutative property for multiplication. And if you had 100 factors, it doesn't matter which one you multiply first, you can still get the right answer or the same answer. Okay? That's what I mean by commutative. Second one, the associative, which people get confused with another property, but hopefully I can further clarify these. All right, the associative property, there's an associative property of addition, and there's an associative property of multiplication. Does anyone know? And you can look in your book. It doesn't tell you exactly what it is, but it shows you examples. What are they referring to when they say associative property? Think of the word associate. I associate with. These numbers associate. Yep, Will?
Is it possible that you can regroup them?
Yes. Groupings. Groupings do not affect. Okay, I'm going to put these little quotation marks. Why do I put the quotation marks? Because I don't want to rewrite affect the sum or product. So you could put these little quotation marks. That means it's the same thing as above. It does not affect the sum. It does not affect the product. So I'm going to put one up here on this board. What I mean by grouping. Please be careful, guys. Associative property doesn't just mean you move parentheses. It means you have to change the grouping. All right, so let me get a multiplication problem here. 3 times 5 times 7. All right, what's grouped together? 3 and 5, right? Okay, if I were to change the grouping, so I got 3 times 5 times 7. If I were to change that grouping instead, what's grouped here? 5 and 7. Do I change the product? Is the product different here than it is here? No, that's the associative property. Do you notice that I did not mess with the order? Because if I mess with the order, what property am I applying there? Commutative. So technically, could you apply both properties at the same time? Yes, but here, what property is being displayed only? Associative. The groupings do not change the product or the sum. Okay, good. I got those down. Let's go with, this is actually out of all the properties my favorite one. You know what it is?
Distributive.
Oh, that's close, I guess. I think I heard it. Identity property. I'm going to give 2 versions of addition and of multiplication, because they're not the same. You can't just lump them together, although they're still identities. Okay, so of addition and of multiplication. What is the identity property of addition? What can I add to any number and not change that number? What do you guys have?
Not a
Excuse me? What was that? Oh, 0. Gotcha. So I'm going to put it here. A plus 0 equals A. Any number plus 0 equals the same number, right? That's the identity property of addition. Guys, I just want to tell you this. You may not see this property in action sometimes, but it's all over your problems. All over. Now, if I point it out every single time, it might get tedious. but I am going to point it out so that you know it's there, and then hopefully you can see it sometimes on your own and appreciate that you have that property and that you don't have to say, what is 7 plus 0? So, no, you just know it's automatically got to be 7. All right, what's the multiplication identity property? Yes, ma'am? A times 1 equals A. A times 1 equals A. So any number times 1 equals the same number. Now, you're like, okay, mister, I knew that fact. That's, by the way, what was the first pretty much, what's the first multiplication fact you learned? 1 times 1. And then you had to go, and then your teacher said, okay, today you're going to learn your ones tables. 1 times 1 is?
4.
1 times 2 is?
7.
1 times 3 is? Right? How many of you like that lesson? You're like, oh, that was so easy. In fact, this year, we're teaching Ezra those facts. 1 times 1 is?
7.
1 times 2 is?
4.
And all he has to do is remember the number, right? Because of that identity property multiplication, it's super easy, and we see it a lot. Okay, next one. This is one of the most helpful properties, the inverse properties of, and we're going to go again with addition. Yes, sir?
Are your kids like math geniuses?
No.
Are you a math genius?
No.
Yeah.
So we're a family of non-math geniuses. Sorry.
You're a math teacher.
I am a math teacher, but not a genius. Yeah, I know. It's sad.
Well, you're a genius at teaching.
Okay, just ask my YouTubers, right? Okay. The inverse property of addition is this, and I'm going to give you a keyword in just a moment. Any number plus its, what do you call this guy? Close. Opposites. Any number plus its opposites equals 0. Zero. 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 Zorro. Okay. Nil. Right? Is that, I don't know why they use that in soccer, nil, but we're going nil. Equals nothing. Any number plus its opposite equals 0, right? Okay. A can be a positive number, but A can also be a negative number. So give me a negative number. Yes, sir, Henry. Negative number. Negative 1? Oh, thank you. What's negative 1 plus its opposite? What's negative 1 plus 1? 0. Okay, so that works for positive or negative numbers. And then the inverse property of multiplication. Yeah, someone's saying it. What is it? We're talking about reciprocals. So A, does anyone know how to write it? A times
1 over A?
A times 1 over A is equal to, though, not 0. 1. I'm trying to convince these 7th graders, you know, the places you were last year. My favorite numbers are 0 and 1 because they're so helpful. In fact, this reciprocal idea, I like multiplying by reciprocal in equations, fractions, division. So I use this all the time, and so will you. And we'll appreciate that more, I hope. Okay, next one. Last one for today. The distributive property. Dun, dun, dun. Okay, guys, I'm going to tell you this. This is one of the most useful properties for doing mental math. Mental math. Is guys, you remember what Mr. A has said about mental math? I'm not that good. I really not. I'm not. So when someone's doing a problem, like do 20 plus 78. Okay, I had to kind of just stop. Got it, 98. Got it, 98. Got it. But it took me a while. Now you throw me a multiplication problem. What's 17 times 4? 68? Is that it? Oh, well, see, some of you are like, yeah, mister, I got that 5 seconds ago. Okay, cool, but I got it still. I'm using the distributive property in my head. Okay, let's look at it here. Hopefully you know what it is. A times B plus C. Okay, the way you know distributive property is coming up is you have something being added or subtracted in parentheses, brackets, braces, doesn't matter, and then something multiplying whatever's inside. So do you see the multiplication here? Yes. Are they addition or subtraction? So what do I get? AB plus AC. Yep, that's it. Another version of it, guys, would be, for example, B minus C, and I'm going to throw times 8. Okay, is something being added or subtracted in parentheses? Yeah. Is something being multiplied by that sum or difference? Yes. So what would I get here?
AB.
I'm going to call it BA minus CA. Is that allowed?
Yes.
You could have said AB minus AC because of what property? You could switch those around. Commutative property, right? Does anyone know what property? Oh man, I didn't show it here, but let's see if you can see this property. Boom. Right here. What property is being shown right here?
Associative. Oh, no, it's just order.
Commutative property. What? There's parentheses. That's not it. Guys, what changed from here to here? The order. The A, instead of being in front, multiplying all that, goes at the end. Did any groupings change? No. So it's just commutative property. So be careful with that. Okay. You love this. The next one, definition. Sorry, I said that was the last property, but there is a definition of subtraction. How do you define subtraction?
The taking of one thing.
The taking of one thing from another. Minusing something. Yeah. Trademark that word, minusing. Okay. The definition of subtraction.
You're subtracting something.
Here's the definition. Adding what? The opposite. That's the definition of subtraction, not that.
Taking something away.
I'm a positive guy, so I'm saying I'm adding the opposite. That's how I'm going to view it. Not taking away, I'm adding to something else. Right? Isn't that what you're doing? When you subtract, you're actually taking, you are taking away, but you're moving it somewhere else, wherever that is, hopefully somewhere good. So here's how the property works. If I have A minus B, how can I rewrite that with addition? A plus negative B. That's what we mean by subtraction. Means literally, and by definition, A plus negative B. Okay? Now, I'm going to tell you this. Sometimes it's easier to see it as A plus negative B, and sometimes it's just easier to leave it A minus B. You have to decide, okay? So if I gave you this problem here, as an example, 10 minus 7, you don't have to say 10 plus negative 7. You don't have to do that. What's 10 minus 7? 3, okay? And what's 10 plus negative 7? 3. So it's the same thing, but leave it as subtraction. But if I had maybe like negative 7 minus negative 8, I mean, you could see it that way, but a lot of you, even if you don't want to admit it, you saw it this way. Stay, change, opposite. What's negative 7 plus 8? 1. So what's negative 7 minus negative 8?
1.
And so is that.
3.
Okay, do you guys get definition of subtraction? You like it, I like it, you use it, I use it. We will be thankful for that. You guys good? Man, I'm moving too fast, right? I feel like I'm on a groove here. You guys good?
Yes.
I'm not going too fast? Too fast for you? Okay.
Do you like adding or subtracting better?
Adding. Yeah, see, we like the same thing.
I think it's better.
Because the definition of subtraction is adding the opposite. Yeah, remember, guys, the definition of subtraction is adding the opposite. It's not the same thing exactly, but it is adding the opposite. All right. Combining. So this is a review of combining like terms. Okay. Terms are important in math. You should know what a term is, but now we're going to look at what like terms are and make sure we understand that concept. So like terms and I'm going to put it differently than I have in the past. I think this is actually more accurate. Having the same literal, here comes that word, literal coefficients. Did we look at that? What's a literal coefficient?
A letter like A.
It's just a variable raised to the same power. That is the definition of like terms. And I'll give you some examples of what like terms are and a couple, maybe an example of what like terms are not, because people get tricked. Like, wait, those are like terms, they have the same variables. Yeah. Do those variables have the same power? No. So they can't be like. Elijah?
Are 1 and 1 like terms?
Yes, they have the same variable. You're like, what's 1 have? X to the 0th and x to the 0th, so they can combine like terms. But also, you can think of them like this. They're both constants, so you can combine them like that. All right, here are some examples of what they are. So one example would be 2a and a. What are their literal coefficients for these two terms? What's the literal coefficient? A. What's the coefficient of this one? 2. What's the literal? Oh, wow. What's the coefficient of this one? 1. If you know the coefficients, you could combine them. What's 2a plus a? 3a, right? 2 plus 1 is 3. 3a. And then another example would be, make sure I write this one, xy squared and negative 2xy squared. Do they have the same literal coefficients? Yes, they both have x and y. Do those coefficients, literal coefficients, have the same powers? Yes, they both have x to the first and they both have y squared. These are like terms. If I were to add these together, I would have gotten negative 1x y squared or negative xy squared. Same thing. Okay, good. Here's an example of non-like terms or unlike terms. So I'll put this to make it clear. I don't want to confuse anyone. Unlike terms. Someone's got to tell me y, m, n, and negative 3mn squared. Somebody tell me why these are not like terms. They are unlike terms. Jack? Angel? Oh, sorry, Jack Hart.
There was the first one, M, and the exponents, they have different like exponents. The second one, because everyone has squared.
Yeah, it's not because one's positive, one's negative. It's not because one doesn't have a coefficient, the other one does. It's because they both don't have the same literal coefficients raised to the same power. That's key. These do not combine. They do not combine with addition. Do you guys get that? Because you're going to see it, you're going to want to combine them, and they're not combinable, fusible, joinable, mergeable. Okay, sorry. You can't do that. All right, here's your actual, this is actually what you're going to be doing for your homework. All right, this is what they want you to do. Now, guys, you can thank me later, because what the book wants you to do is much, much longer than what I have you do. You're welcome, Will?
Thank you.
Awesome. You welcome, Justin?
Thank you.
Ellie, you're welcome?
Thank you.
Awesome. All right, thank you. I feel that thankfulness. Okay. Okay, what's cool about this, I wish we could do it, but I don't want to waste our time. You're gonna simplify these expressions, and you're just gonna tell me what property you use. You can abbreviate. Okay? I'll show you how you can abbreviate. But guys, if you're really being technical on this problem, 6 steps. I have 3 steps. Okay? So are we okay with that? All right, first step. What would you do first to simplify this expression? This one.
Well, I was going to do distributive property.
That's it. Yeah, you're going to distribute. So you would get 3 times m plus 3 times 9, and then plus my 2m. So what you do here is you write your work, and you just put distributive. That's all you do. You got to justify. And in fact, guys, you know what it says? Justify your answers
Is this what you can, is that all you have to do
for that first step.
for justifying your answer?
Yeah. So I'm not done yet because can I simplify this anymore? So here's what I want you to do, guys. I do want you to do this one. Okay. Oh, man. You could break this down into the 6 steps, but all I'm going to have you do is this. Are there any like terms?
Yes.
Okay. Okay, yeah, do this. I want you to put like terms together, okay? So I'm going to rewrite this. Oh, I know.
Write that out?
Yes, write it out.
Can we just like underline it? And
No. because I want to see it line by line. I know.
You're right. That's the same thing.
Hey, how about this? If you do it well enough for tonight, then I won't make you do it for your test.
Well, Miss Barrett.
You won't have to show me every step.
Okay, that's a deal. It's a deal.
Deal or no deal? All right.
But isn't that just the same thing?
What's the property being applied? Commutative. How did I know it was commutative, by the way? I switched.
For every step.
Hold on, I'll show you the next one. I switched the order. Okay, I just switched the order. All right, now here's where I'm saving you some work. Technically, when I combine like terms, I'm using the associate property and the distributive property and the substitution property. Okay, I'm using all three of them, but all I want you to do is combine these two, and what's 3n plus 2m? 5n. And then plus 27, and just write add like. You can even just add like t if you want, or you could say te, is it ter or te? Okay, you could do that too. I was trying to ease you into it. Oh, he's okay with t. Te maybe terms. Just write that down. You're done. That's it. Done. Yeah, and then I'm not giving you a ton of problems because you have to do that in each one. Okay, so now let me give you another one. I'm telling you guys, this problem right here, this problem had 1, 2, 3, 4, 5, 6, 7, 8, 9 steps that they wanted you to put, and I have 3.
Why would you need 9 steps?
Okay, remember what the instruction was on this problem? It said to not only work it out or simplify, justify it. What I'm trying to draw the point to is that these properties are so important. If you did not have them, that cannot be simplified. Okay, that's all you're left with. You're like, cool, then our answer is just what they gave us. Yeah, try to use that in real life. Try to use that in any engineering, any accounting. Just try to use that anywhere. It's like, man, if I could just make it smaller. Let's see what happens when we make it smaller. First step, Nelson. Distribute. Yep, I'm going to do 7 times y and 7 times 2, okay? And I can distribute twice, right? Because I can do it over here, but be careful with this distribution right here. What am I multiplying y and 8 by? Not just positive 5, negative 5. What's negative 5 times y? Negative 5y. What's negative 5, bless you, times positive 8? Negative 40. So you don't have to deal with that subtraction sign in a hard way if you just say, hey, that's negative 5. But I have a question. What's going on between this and this? What was technically going on there? Subtraction. But we know the definition of subtraction is adding the opposite. So technically, ready? What's 5 times y?
5y.
What's 5 times 8?
40.
What's the opposite of 5y plus 40?
Negative 5y minus 40.
So you use that definition of subtraction there. All right. What do you think I want you to do next?
Put the things.
Good. Like terms together, like write them together. And there is a reason why, distributive. There is a reason why I want you to do that. It's because I want you to manipulate expressions.
The 7y comes first.
You could have put the negative 5y first plus 7y. Yeah, so you have variety. Yep. And that's because of the?
Commutative.
Property. The property. Property is
It's a
Commutative, yeah. You could have moved this in front, that one after. Okay, and then add these. What's 7y minus 5y? What's 14 minus 40? Oh, 14 plus negative 40, same thing. Negative 26. And you just, you know what? I'll do this. Like terms, right? You just combine like terms. And technically you could say combine like terms because you could have done it by adding or subtracting, but you can also say adding because you could turn subtraction into addition. All right. This stuff is deep, guys. Did we make up these properties? Like, did someone just come up and say, you know, I'm just smart at math, I'm going to come up with a property, and we said, yes, that's a good property. No, guys, think of it this way. Okay, you have $5 in ones, right? You have 5 $1 bills. You have 6 $1 bills. And you have 4 $1 bills. And I want to count them up. So I'm like, okay, 5 plus 6. I got my 10 plus my 4. Okay, 14, right? Right? You can add that way. Could you have done this? Could you have added Henry's first, and then Darius's, and then last Sophie? Could you do that? Yes, it's a natural property. You see it all the time. You do it all the time. So, yes, we can apply it. So God created that, and it works. Okay, awesome. Homework. What time do I have? Someone have the time? 1:45? 11:40, sorry. 11:45. Hold on. Sorry?
Is 5 plus 6 10?
Oh, I'm sorry. Yeah. Okay, I thought it was 4. I'm sorry. I'm going to cut it down. Mental math? Bummer. Yeah, I need to work on that. 2 to 16. It was going to be 2 to 20, but... Okay, we'll just go with that. 17 and 18. Now listen to me, guys. On numbers 8 and 10, you just had to write the property that A, B... I'm telling you how to do it right now to make it easier. On numbers 8 and 10, guys, all you have to do is for A, just write down commutative property, or distributive, DIST, or associative, just write ASSOC. Just make sure that it is clear which property it is. That's for 8 and 10. Just tell me which properties be there.
So,
Tell me what property and what number fits that N. What number fits for N? There's only one number that would fit for N.
oh.
So after, when we figure out the number,
Yeah, for 8 and 10.
the only for 8 and 10 we do.
You're going to do that? Okay, but then 12 and 16, you're going to work it out and tell me your property.
But after each line.
After each line, just put that, but put it on your paper, yes. Label it A, B, C. And then listen, for 2 through 6, you need to put the number that fits her N. There's one number that fits her N, and then tell me what property it is. Just abbreviate if you want. All right, goodbye, Swivl.